Hello, good evening, everyone. It's your boy, Toby Famutini. You can call me T Fams for short. I'm your safety engineer back again, and today we're going to be talking about various equipment you find on P&IDs and oil and gas installations. I'm not going to be talking about valves or major equipments like vessels or pumps. I'm going to be talking about those little things you see which might cause a little bit of confusion that take or you they usually take you back to your legend, and you have to read a bit to understand them. They're quite commonplace, and if you read P&IDs a lot, you'd be used to seeing them. Stuff like bad tees, like removable spool piece, or an RO restriction orifice, this kind of stuff. So yeah, so today I'm gonna start um, yeah, so this is your channel, of course, promoting safety engineering, and please subscribe. When I pick up our little equipment, I'm gonna define it. I'm gonna show you pictures in the P&IDs, so you have an idea what it looks like in the P&ID, and then on site when you see it in on an installation or a facility, you would okay, this is what it looks like. So I'll be showing you actual pictures of the equipment and symbols of what they are on a P&ID. I would also give you a little bit a definition, and then maybe a layman explanation of what it is. So we're starting off with bar tees, and what your bar tee would look like would be something like this. How do I have it here? Yep, this is a bar tee. So let me zoom in a bit. This is what it looks like. It's just like a T, which is upside down, and it could be the right side up depending on where you find it. And this is what it looks like actually in real life. Now, what it is, the definition is a bad T is a T kind of fitting as a fitting with a branch used in pipelines that is peaked and has a restriction bar welded internally, preventing the peak from traveling down a branch connection. So, okay, let me show you what it looks like in also here. This is also in part C. This is what it looks like on site. Being connected to a pipeline, you might or piping, you might not actually pick it up, but it's there. Most times it's used around peaks. And in your P&IDs, this is what it would look like. I showed you an example earlier on, but this is it also. This is what you call a bad T. A bad T, so here it is. So, okay, what it does is if you're going to pick this line, that's using a pipeline inspection gadget or intervention gadgets to clean the line or to they're used for various things. I would explain it further in some other videos, but you put a kind of device or a device into the pig around here, and it goes down the pipeline cleaning it or measuring the thickness of the walls. They have various uses there for the pigs. So what the Bati does is it stops the pig going in the wrong direction. That's why you see those little restrictions here, these bars here. It actually stops, so it allows it to go just in one direction. It wouldn't allow the pig to get stuck here. The pig moves with the flow of the fluid in the pipelines. So normally to pick this kind of line, you put in the pig, you would have to have this closed, then when it's you have to now divert the flow back through this and all the way into this pipeline this way. So you would have to open this. It's something you do periodically. It could be once in 2 years, once in 5 years, just to check the thickness of the line and some other various information you might need. So that is a bad T, and this is what it looks like. Yep. Uh, here. These are various bad T's, and this is what it looks like. So this is the restriction here. Okay, so that's talking about bad T's. And after that, we're going to go to a blind flange. Now, this is what a blind flange looks like. It's just a flange at the it's a flange, but it's actually sits at the bottom of a valve. And the definition is a solid flange as shown below, as shown here. The purpose of this is to block off a section of pipe or a nozzle on a vessel that is not used. So let me show you what it would look like in a P&ID. So it's just a normal flange that you see every day, but here the way it's represented on a P&ID, it's just an extra line below a valve. So it actually stops the flow. It's mainly to stop double jeopardy. Like in this situation here, you can see a line after the valve. Let me zoom in really well here. So this you could say is blind flanged, meaning after the valve, you would have a flange sitting at the bottom. And the reason why this happens is in case there's flow going through this line, and then someone could actually come here and open the valve inadvertently or by through some sort of human error, and then you just have flow going out here, and then it defeats the purpose of of passing fluid through the pump. So why that flange is there, even if you open this valve, there wouldn't be any flow because the flange would still be sitting in that position, and it wouldn't allow anything to go through. So even when you get there and you want to open it, you would see it's blind flanged, and you would know, okay, there's no there. Even if I open this, there's not going to be any flow anywhere. So it's like a protection, like I can stop to stop an error. And in case that happens, that means someone has actually done something deliberately. That means the person has opened the valve and also removed the blind flange, removed all the connections and the pieces. Yeah. So it's also here. This is what you call a blind flange also here. So a lot of times it's used as drain valves at the bottom of vessels, or at the bottom of compressors. It could be a pump. There will be a flange. So it's normally used also for draining the line, but so that you need a minimum retention of fluid in this drum, and so this valve would always be closed. So in case someone actually opens this up inadvertently, this line would, this flange would still have everything locked up in the vessel. Okay, so that's blind flange. And then we would go to a Y strainer. Let me talk about a Y strainer. And what that does is a strainer is actually used to um, clean out a flow. If there's flow going in a direction, you can open out the strainer and drain everything in that, should I say, in that line. It's so this is a picture of what it actually looks like, and that's why it's called a Y strainer. And this is what it looks like in a P&ID. This is it, and here there's a valve after it. This is it also, there's a valve after it. So it picks up whatever could be some form of, should I say, dirt, whatever it is, and a lot of times it comes up before pumps because you don't want to clog up the pump with depth, with impurities in the line. So this is it. This is what you call a Y strainer, and it will gather all the impurities here and then allow flow to go, good flow or clean fluid to go through to the pump. That's what a Y strainer is used for. Let me bring it up again. Okay, note these parties. So this is also a Y strainer. Yep. So flow going from here to here, and this would catch the impurities. Yep, and you can also open it periodically for maintenance and empty it out. Then from there, we're gonna go to a conical strainer, which is like a bad seed, or which is like a wide strainer also, but this is a cone in the line, and it could be going against the flow or towards the flow. All it does is actually, it's like a sieve, and it catches all the impurities in the fluid, and stops them from going to whatever equipment like a filter. And if and periodically we come bring out the conical strainer and clean it. So sometimes, depending on the scenario, you might need a conical strainer, or you might need a wide strainer. From there, we would go to a drip pan. So, okay, drip pan is normally at the bottom of skids, and it's used to catch, like during maintenance, or for whatever reason there's a leak in your vessel, in your pump, in whatever it is in your equipment, and there, instead of the fluid just draining all over the flowing all over the place, it traps, catches the fluid. So maybe during maintenance, you open some valves, the fluid will drain into the drip pan. So on a P&ID, this is what it would look like. At the bottom, it's normally at the bottom, and this is a drip pan. Here, this line is what you would call your drip pan. So it's to catch whatever is coming from here, whatever fluids, whatever liquids are coming from here. Maybe when you drain, when you open this up, it all comes down here. Same here. This is what it looks like. Drip pan. And you see it's at the bottom of this kit of pumps. This is a drip pan. So it just tracks. This is just what it looks like on a P&ID. But in actual life, this is what it is like. This is it at the bottom of this. This is a chemical injection skid, and this is the drip pan at the bottom. So whatever fluids come from here all go into this place and don't mess up the floor. It's very, very helpful because you have various kind of liquids everywhere, and you don't want the floor looking all messed up in your site. Yeah, you want to have good housekeeping. So, and then from there we'll go to a manifold. Now, a manifold, this is what a manifold looks like. It normally looks really confusing, but you have your P&IDs to guide you when you're working on the manifold. Now, this is what it looks like. A manifold is a wide or bigger pipe or channel into which smaller pipes or channels lead. Also, is a section of pipe that has built-in ports and is designed to distribute flow. There are control centers that control how fluid is distributed to parts of the system, various parts of the system. So this is what it looks like in a P&ID. So this is, you could say all this is a manifold, this entire area. So you have different valves all going to, all you could all line them up in such a way that they would all go into one line, or go into this line, or go into this line. And based on that, it could go into different kinds of, should I say, instrument equipment. So maybe HP separator, LP separator, or test separator. So you have to line them all up. So let me show you what a picture of it looks like. A full picture of it. This is what a manifold looks like. Do I have a clearer picture? Yeah, I think this is a bit better. Can you see all the valves? And depending on where you want it to go, you could line it up. So for instance, now all these are coming from wellhead. This is from a set of wellheads. This is from another wellhead. This is from another wellhead. So you might, the reason why you have it this way is you might want everything from all three wellheads to go to the TP manifold. That's the test separator manifold. And you might want everything to go to the HP, high pressure manifold, or you might want it to go to the LP manifold, depending on how you're producing or the strength of the wells, because they deplete over time, the pressure regime. So you would have to line them all up to go to one direction, and you might want to run two vessels at the same time. So you would line it up. One would be out of service and 2 will be flowing. So it all depends on the arrangement of these valves, which you open, which to close. There's some that you can see this is open, so the flow should go this way and come here. But and you can see that this, if you open this now and open this and close this, the flow will go into this line. And if you close this, close this, the flow would only go into this line. So, and the same for here and the same for there. You can rewatch the video and see the explanation, but yeah, it's very necessary and important when you're running a hazard or designing a P&ID to understand how you want to isolate some lines and flow some lines. So yeah, that's it about manifold. Let me show you the last picture I have. So it's just a collection of pipes with valves which directs flow to various parts of the system. Then I want to talk about your reducer. This is a tiny object that you find a lot in your hazards, in your in your P&IDs, and yeah, this is what they are like. A reducer is a kind of pipe fitting that reduces the pipe size from a larger bore to a smaller bore, and for an expander, it's vice versa, meaning it's increasing it from a smaller bore to a larger bore. So this is what it looks like in P&IDs. I'm sure if you've seen P&IDs, you would have come across them a couple of times. See that here by this uh, pressure control valve. So this is a reducer. You can see from 12 times 6, it would always be on the P&ID, the size you're going from to the size you're reducing to, or the size we are reduce the small size to the large size, the large size to the small size. So this is the direction of flow. You can see the arrow here and it's going this way. So this is a reducer. So you're going from a 12-inch line and then it drops to a 6-inch line. That's why this is 12 times 6. So it drops to a 6-inch line. And after going through this valve, this pressure control valve, there's an expander going from a 6-inch line to a 12-inch line. So that is actually what they there for. So sometimes the line you might want to reduce it for various reasons. Maybe you want more pressure, or for various reasons you might want to do that control of the flow. So you put an expander, like, okay, coming from here, I want an expander to increase the bore, or you might want a reducer. And this is what they look like in real life. Pretty simple, boring. Then we're going to a removable spool piece. This is very, very good in times of, especially when you're having when you want to do some quick maintenance. A removable spool piece is a short segment of pipe that is usually intended. It's such section of pipe usually intended to be removed either for service or as a stand-in for a valve or other fixtures to be installed at a later date. So this is what they look like. It's just a piece of piping, really. It's just you can see it here, a removable spool piece. It has flanges. You just go there, put it out of the system. This is one here. This is a removable spool, and that's the logo. That's what it looks like in the P&ID. Let me show you here what it looks like. Okay, this is it here. Let me zoom in better. Yeah, that is a removable spool piece. Also here, let me show you what it looks like. So it's just a piece of piping. Okay, this is removable spool pieces. Here, 1 and 2. Very, very good. And next, we're going to be talking about an arrow. It's a restriction orifice. I don't have any P&ID showing this, although it comes up all the time. You see them in P&IDs, but I don't just have any at hand here. And it's mainly used to achieve controlled or restricted flow of a process medium. The orifice offers a restriction to the process flow from the pressure head drops flow, and the pressure head drops from the upstream to the downstream. So it's normally used for a pressure drop from upstream to downstream. So coming from a place of higher pressure, and because it's actually the bore of the piping might be this big, but because of this restricted surface for it to go across, this restricted bore, the pressure drops when going across. The piping on the other side is the same size. So it's not like a reducer or expander. It's just reduces the bore of the piping to ensure that pressure is dropped across the restriction orifice. It's used a lot. It's very, very necessary. And then after that, we have what we call a spectacle blind. We call it a spec blind. Now, this is necessary for positive isolation, and it's you see it a lot before major equipment or after valves. This is what it looks like. This is it in an open position, and that means the black dot on top, that shows that it's open. And if you have a black dot below, that means it's closed. So this is a spectacle blind. This is a spectacle blind. It's very, very necessary. um Let me show you what it looks like in real life. So this is it. On this side there is a ring with a hole in it, so it allows flow to go across. The hole is the same bore as the as the as the pipe diameter. And what's it's like a flange. It's cut to fit between two pipe flanges. Can you see this is a two pipe flanges? So it fits in between those, and is usually sandwiched between two gaskets. It's often made from two metal discs that are attached to each other by a small section of steel, and they're installed as a permanent device to separate process piping systems. So you use it for isolation. Like you want to work somewhere here, you would come open the flange and roll it across. Let me show you what the other ones look like. Yes, so this is it when it's open, when it's closed. So the other part that is a disc is here, which there's no hole in, and this is the path where there's a hole. So if you want, like this is closed, if you want it open, then it would become like this. So the other part would come out, and that's why it's nicely represented that way in the P&ID here, here, and it's used to isolate. So if you want this vessel out of service, you would just come, open the flange, swing the spectacle blind across, and bolt back the flange in place, and yeah, ta-da! Have no flow into this vessel. And it's, you can see it at the end of this nozzle here also, and yep, you can see it here at the gas outlets. So it's always, oh, it's used very much. You come across it a lot. And when starting up, if this is closed, you might not be able to start up your system because you wouldn't be able to pressurize the entire system. Yep. So next we'll go to a spec brake. And what a spec brake is oh, it's for functionality changes. It shows up on P&IDs. You can't actually pick it up on site physically, but unless you actually know what the metals look like, which most times they're painted. So it's for functionality. It changes. It's to show a change in specification of a pipeline, uh, and such changes are because of change in pressure regime or a change in temperature regime or for various reasons. So you might have, so this is what it looks like. There's a little line coming down, and then from, it's showing that this section of piping is API 5000 according to this drawing, and this section of piping going further down is ANSI 600. And that's, yeah, same here. It shows that this section of piping is ANSI 600 and this section of piping is ANSI 150. So it could be a 300-pound line or a 150-pound line depending on the amount of pressure the line can take. And yeah, that's where you find that's how you find them and the uses. Same here. This is it, A3B to A1A. It's very necessary in a hazard to pick this up. or as a process person not to make this error, because that's what changes the piping specification. You don't want to make that error of because whatever this pipe might be designed to take, even if it's 16 inches and this is 16 inches, this might be okay with stainless steel and this might not be okay with stainless steel. So you'll want to make sure you indicate it very clearly on the P&ID, so that as the hazard is going on or as the design is going on, you would know, okay, this this area is supposed to see so amount of pressure. This piping might not be able to take that kind of pressure because it's rated for 300 pounds or rated for 150 pounds or 600 pounds. So those are the kind of thing that's very necessary, and you would have them popping, just showing up at some places. It's always good to take note of them and not make an error to, like here also, this is a spec break. This has a lot to do with the piping team. So from pipe 61410 to pipe 11410, and that's would be in the piping specification. And yep, so that's it for today's class. Thank you very much for listening. Do not forget to subscribe. Name is Toby Famutimi, T Fams for short, and don't forget to subscribe. Thank you very much for taking out the time to listen. Have a lovely day. Bye bye.